CrowdStrike's disastrous software update in July left millions reeling. The fallout from this catastrophic blunder is nothing short of heartbreaking, and it has affected over 8.5 million Microsoft users. Now, they have released the root cause analysis of the faulty software update, which is more embarrassing and outrageous. If you want to find out how this happened, keep watching. Well, it was supposed to be a routine software update, a minor tweak to improve the detection capabilities of a leading cybersecurity product. But on July 19, 2024, the innocuous update spiraled out of control, causing what may go down as the largest global IT outage in history. The culprit was a simple programming mistake, the kind that first-year computer science students are taught to avoid, and the fallout was staggering. It all started with CrowdStrike, a cybersecurity firm that provides ransomware, malware, and internet security products, primarily to businesses and large organizations. On that fateful day, CrowdStrike pushed out an update to its Falcon sensor software, a core component installed on millions of Windows systems around the world. The Falcon sensor sits at the kneel level of the operating system, giving it deep visibility and control over system activities. This privileged access is what makes it so powerful in detecting and blocking threats. But it also means that when something goes wrong with the Falcon sensor, the consequences can be catastrophic. And that's exactly what happened. CrowdStrike's latest rapid response content update, designed to keep Falcon sensor's threat detection capabilities up to date, contained a critical flaw. The company's root cause analysis revealed that the update expected 21 input fields, but the sensor code itself only provided 20. This mismatch, combined with a latent bug in the sensor's content interpreter, resulted in a system crashing out of bounds memory access. When the faulty update hit the millions of Windows systems running the Falcon sensor, it triggered a cascading failure. Computers around the world started experiencing the dreaded blue screen of death, rendering them unusable and unable to be rebooted. CrowdStrike CEO George Kurtz was summoned to testify before the U.S. Congress, facing tough questions about how such a basic programming mistake could have slipped through the company's quality assurance processes. The preliminary damage assessments were staggering. In Australia alone, the impact on businesses was estimated at over $1 billion, and Delta Airlines claimed the outage cost them $500 million. But the true cost went far beyond just the direct financial losses. The cascading effects of the stock market crash reverberated through the global economy, wiping out trillions in wealth, shaking consumer confidence, and raising the specter of a prolonged recession. Well, how could this happen? The root of the problem lies in the way CrowdStrike's Falcon sensor was designed and integrated with the Windows operating system. As a kernel-level security product, the Falcon sensor has deep access to the core of the OS, allowing it to monitor and control critical system activities. But this level of integration also means that a seemingly minor bug in the sensor's code could have catastrophic consequences. In this case, the issue stemmed from a mismatch between the number of input fields expected by the sensor's content interpreter and the number of fields actually provided by the rapid response content update. This discrepancy triggered an out-of-bounds memory access, causing the entire system to crash. Experts say that even basic quality assurance checks should have caught this problem. It's the kind of basic programming error that first-year computer science students are trained to avoid. But somehow, it slipped through CrowdStrike's development and testing processes with devastating results. In the aftermath of the CrowdStrike incident, the cybersecurity and technology community has been grappling with some hard questions. How could a mistake so fundamental slip through the cracks? And what does this say about the overall state of software quality and security in critical systems? One of the key issues that has come to light is the sheer complexity of modern software stacks, especially in the realm of security products. The Falcon sensor, with its deep integration into the Windows kernel, represents just the tip of the iceberg. Across industries, we're seeing an explosion of sophisticated, interconnected software systems that are responsible for powering everything from financial markets to power grids to transportation networks. As these systems become more complex, the opportunities for subtle bugs and vulnerabilities to emerge also grow exponentially, and the consequences of those failures can be catastrophic. as the CrowdStrike incident has so vividly demonstrated. Siki Good, a professor of information systems at the Australian National University, notes that the problem goes beyond just CrowdStrike's quality assurance processes. This kind of mistake shouldn't be happening, he says. First-year programming students are taught about the stack and the series of instructions that need to be executed in a CPU. The fact that the CrowdStrike developers were able to have this obvious inconsistency between the data file format and the software code means that the most basic forms of quality review and assurance were not being correctly carried out. Toby Murray, associate professor at the University of Melbourne School of Computing and Information Systems, agrees. The dodgy data file update was incredibly embarrassing, he says. Even basic checks by a human developer would have found the problem. The fact that it slipped through is a major indictment of CrowdStrike's quality assurance processes. However, the issues go beyond just one company. As software systems become more complex and interdependent, the potential for cascading failures grows. A bug in a seemingly innocuous component can have devastating ripple effects, as the stock market crash has demonstrated. This raises fundamental questions about the way we approach software development and deployment. Do we need a more rigorous, standardized approach to quality assurance and security testing? Should there be greater transparency and customer control over the deployment of updates? And how can we build more resilience to withstand the inevitable failures that will occur? These are questions that the technology industry, regulators, and policymakers will be grappling with in the aftermath of the CrowdStrike incident. The stakes are high, as the stability and security of the global financial system and critical infrastructure hang in the balance. One thing is clear. The days of treating software as a black box with occasional updates pushed out without rigorous testing and customer oversight are over. The CrowdStrike incident has exposed the fragility of our technological foundations and the need for a fundamental rethinking of how we develop, deploy, and maintain the systems that power our modern world. In the meantime, the fallout from the CrowdStrike incident continues to reverberate. Lawsuits have been filed, investigations launched, and the company's reputation has taken a major hit. But the real cost may be the erosion of public trust in the very technologies that we've come to rely on to power our financial systems, our infrastructure, and our daily lives. Experts argue that the current state of software development and deployment is simply not sustainable, especially for mission-critical systems. We can't keep treating software as a black box with developers pushing out updates without proper oversight and testing, says Sigi Good. The stakes are too high, as we have seen with the stock market crash. Professor Toby Murray echoes this sentiment, noting that the CrowdStrike incident should serve as a wake-up call. This wasn't just a problem with CrowdStrike's processes. It's symptomatic of deeper issues in the tech industry. We need to fundamentally rethink how we approach software quality and security. One potential solution that has been floated is the creation of a new regulatory framework akin to the stringent safety standards imposed on the aviation or nuclear power industries. This could involve mandatory third-party audits, staged rollouts of critical updates, and strict reporting requirements for any software failures or vulnerabilities. We're talking about the stability of the global financial system here, says Good. The same way we have rigorous safety protocols for airplanes or nuclear power plants, we need to start treating mission-critical software with that same level of scrutiny and oversight. Another key area of focus is the need for greater transparency and customer control over software updates. The CrowdStrike incident highlighted how a seemingly innocuous update could have such far-reaching consequences, and many businesses and consumers now demand more visibility and control over when and how updates are deployed. Customers need to have a say in how these critical software systems are maintained and updated, says Murray. We can't just let companies push out updates at will without any ability for the end user to review and approve them first. Some technology companies have already started to respond to these demands, with CrowdStrike and others announcing new features that allow customers to stage and control the deployment of rapid response content updates. However, experts argue that this is just the tip of the iceberg, and that we'll see continued pressure for more robust customer control and transparency around software maintenance and updates. Underlying all of these discussions is a fundamental rethinking of the role of software in our modern interconnected world. The CrowdStrike incident has exposed the fragility of the digital infrastructure that underpins so much of our economy and society and has raised urgent questions about the need for greater resilience and redundancy. We can't keep treating software as a black box, with developers pushing out updates without proper oversight and testing, says Good. The stakes are too high, as we have seen with the stock market crash. As the technology industry and regulators work to address these challenges, the CrowdStrike incident will likely continue to cast a long shadow. So, what do you think? Are you concerned about the fragility of the software systems that underpin our critical infrastructure and financial markets? Let me know your thoughts in the comments below. And don't forget to subscribe.